All right, so our aims today are twofold. We're going to find the distance between two integers using a number line or evaluating an absolute value expression. That's number one. And number two, we're going to switch between expressions, number lines, and verbal descriptions of integer addition. So it's kind of two different things that we've got going on today. So looking at the first one, we're going to start with a really easy example of talking about the distance between two things, 7 and 3. I think most of you could probably do that in your head. What's the distance between 7 and 3? Yeah, see people showing me with their fingers. I really like that. All right, 4. And we can see this on a number line. It looks like this. Now, one thing that we notice about this is the way that I've drawn it, once again, draws that relationship with absolute value because I'm using the double arrows. Distance doesn't really care which direction. If I were to write an expression, if I want to know the distance between 7 and 3, or I want to know the change from 7 to 3, what expression would you write? Jacob? 7 plus negative 3. That definitely works. That would suggest to me more of a directional approach to it because you'd be thinking about 7 plus negative 3. Actually, that wouldn't even get me to the right place. Think about that. 7 plus negative 3. Oh, no, that would work. There we go. That's good. That's more of a directional approach. I want to think more universally, and Jacob's answer is totally correct because it's actually just a derivation of what I'm about to tell you. Anytime we're talking about the change in something or how things change or the difference between them, we always talk about it in subtraction. In physics, we talk about the word change a lot. We've talked about this word delta. Okay, when we talk about delta, we're talking about the change in something is usually the subtracting of what it was and what it now is. So it's the same thing here. The only difference is if I want to subtract 7 minus 3, which is basically what Jacob told us to do. He just did a leave chain switch. 7 minus 3. Sorry. That's going to tell me how far it is between them. However, the problem with that is that assumes a direction. What do I mean by that? Well, that means that assumes that we're going from 7 to 3. But I don't really care. What if we're going from 3 to 7? I want to get the same answer. Using what we know and kind of thinking about the relationship between this and the concept that we learned yesterday, what do you think I could possibly do to make sure that both of these expressions come out with the same answer to describe a non-directional distance? Talking about yesterday, what did we do when we didn't care about direction? What did we use? Callie?
Absolute value.
Absolute value. So kind of linking that with what we're doing today, I don't really care about direction, so I'm going to use absolute value to make sure that both of these expressions really just tell me the distance without a direction. I want to make sure that these are two the same. This is going to tell me a non-directional distance. How does that work? Well, let's look at it. I want to do what's inside the parentheses or inside the absolute value symbols first. And I find in this particular case, 7 minus 3 is 4. That's going to give me the absolute value of 4, which is, everybody, the absolute value of 4 is 4. Now over here, I have this, I need a leave chain switch. And I end up subtracting these two values and taking the sign of the number with the larger absolute value. So I get the absolute value of negative 4. And the absolute value of negative 4 is 4. So what you can see here is when we're describing distance, because I'm not telling you that it's going from negative 3 or from 3 to 7 or from 7 to 3, I don't care about direction. And the way that I get rid of that direction is by putting the absolute value symbols around it. So I'm going to ask that question backwards to you. I'm going to see if everybody can answer it. Why am I using absolute value here? Jaquan?
Because you use the arrows and it doesn't matter what direction you go into, and it doesn't matter what kind of operation you do.
Alright, so Jaquan has said it kind of two different ways. He's saying, number one, I'm looking at this visually, and I'm saying you're using the double arrows, which reminds us, kind of the second piece there is that I don't care what direction it is. And so we can use absolute value to get rid of direction. Alright, so the next one says, what is the distance between 7 and negative 3? Alright, so 7 and negative 3. And if I want to visually represent this, I can again do that with the double arrows because I'm just looking at the distance between them, not the distance from and to. That means we don't want a direction on this. So I want to write an expression for this. Again, I'm going to be trying to find the change here, but I want it to be without direction. So the first part is to be able to find the change. What's the change? How do I write an expression to represent this change here? This is that part I was talking about earlier. You got to have your brains engaged. You got to be ready to think. Show a little grit, a little tenacity to think through this problem, even though maybe it isn't the first thing that comes to your mind. How is it that I can write an expression to represent the change from 7 to negative 3? Leah G. Okay, 7 plus 3. And I think you're thinking ahead here. And I like what you're thinking at, because you're saying to yourself, you know the answer's got to be 10, right? Because we're looking at our number line. We know the answer's got to be 10. And so she's taking the 7 and the 3, and she's saying, how can I make this fit? And this is actually a really good problem-solving skill. It ends up being 7 plus 3, but I want to make sure that we know why and where that came from. Kelsey. 7 minus negative 3. So anytime we're talking about change, we're talking about a subtracting difference between them. Now, we did say that we wanted distance and not a difference, so we needed to make sure that there was no direction on this. So what is it that I need to do with this expression to make sure that I get rid of the direction on it? Brandon? Absolute value symbol. So I'm going to put this in absolute value. Now going back to what Aaliyah G said, is that when we've got this, we're going to go ahead and switch it in order to do the math. And that's going to give me 7 plus 3. Okay? So that's... Ooh, disaster. Alright. That's mostly fixed. That's good enough. Alright. So where were we? We were... Yeah. So the absolute value of 7 minus negative 3. So we leave chain switch it, and then when we do that, that gives us the 7 plus 3. Shows us we're looking for the absolute value of 10. The absolute value of 10 is 10. And so now we have our distance without a direction. The reason we ended up with that distance without direction is because we put out those absolute value. Let's do one more. Distance between negative 7 and negative 3 on the number line. So negative 7, negative 3. So I want to know the distance between these 2 points. I've already proven the answer's 4, but we also need to be able to know how to write an expression to represent this. So I want to start by knowing how to find the change, or the difference between the two of them. What expression can I write to find just the difference or change between the two of them? We always calculate the change between two things the exact same way. So this is where, if I was sitting in your place and I didn't know what to do, I would be thinking about a really easy example. Maybe I'd be thinking about this first example we did. 7, the difference between 7 and 3. I wanted to know the change between that, and you guys told me it was really easy. I did what? Subtract. So, if that's my really easy example, if I want to know the change between -7 and -3, I want to subtract. So I have -7 minus -3. Now, because I don't want a direction on this, though, there's one extra piece that I have to do. Because it says distance instead of just difference, or distance to, or distance from. What's that extra piece that I have to add on here because I don't want a direction? Mina? Put the absolute value symbols around it. So again, thinking about absolute value symbols mean that we're taking off the direction. So now if I wanted to evaluate this expression, I'd have to start by leaf change switching, which would give me -7 plus 3. If I add those together, it would give me -4. So I'm looking for the absolute value of -4 because I want to know the distance without a direction. Kelsey? +4. So we're finally getting to the point where we're able to come back to key points. There are 2 key things that I really said here that I think is really important to walk away with. Number 1 has to do with how we find the change. So I'm going to cut off some space for me here. How do I find the change or the difference between 2 things? Again, you can go back to that first example and think to yourself, well, I wanted to know the change or the difference between 7 and 3. What did I do, Jasmine? Yeah, to find change or difference, this is our first key point. I'm going to use the delta, change or difference. I'm going to subtract. Really easy key point. No matter what you do, this will always be true. If you are trying to find how something has changed, you can always subtract. Now, depending on what you're doing it for, you might need to know a certain direction. But if we're talking about distance, has no direction. So in order to get rid of a direction, mathematically, what do we use? Need some other brains engaged here. In order to get rid of direction, what do we use? Mason? Yep. So we use absolute value. So those are our real 2 key points from this first half of the lesson today. Number 1, if we want to find the change of something, we always subtract. Number 2, if we want to take off the direction, which we do in the case of distance, we use the absolute value symbol. And when we put those 2 ideas together, that gives us kind of this very summary problem down here. I want to show an expression to show me the distance between A and B. I'm not going to tell you anything about A and B. We're going to use A and B. So if I want to find the distance between A and B, first of all, I have to find the change. So how do I find the change between A and B? Sammy? Subtract. A minus B. Now, if I want it to be distance without a direction, what do I need to do? Lola? And you have suddenly written a formula and created a formula that you can use for the rest of your life. And you will never have to look up because you will always remember how to create it on your own. And this is a formula for the distance between 2 points. Anytime you are given 2 points and you need to find the distance between them, this will always work. And what that looks like, doesn't matter what A and B are, where A and B are, it's going to show you this distance. That is aim number 1 for today. Aim number 2. Aim number 2 is revisiting some of the work that we've done over the past 2 days and thinking about different ways you may be asked to deal with this. Sometimes in the real world we are given a solution in a sense and we have to find the problem. And other times we're given the problem and we have to find the solution. Kind of what that means is sometimes I may know how many students are going to be in this room. So that means I have to figure out how many pencils or whatever I need. Or sometimes I may be given the number of pencils and being told to figure out how many students I can have in my room. So we're going to think about that here. We used to be given an expression and being asked to create the number line. Here we're being given a number line that has a visual representation of some sort of integer addition, and I'm asking you to create the expression. So it says use the number line above to write the expression that it represents. So if we think back to the way that we use these number lines, the arrow tells us that we started here. So that's the first part of our expression. And where the arrow goes tells us what we did. So I see that the arrow goes to the left, so that means we added what type of number? Yes, love it. Love the hands now. Crescent. A negative number. And how far that arrow went tells us what that negative number was. So I see that negative number goes 1, 2, 3, 4. So it's 5 plus negative 4. And we can see that that equals 1. So we've actually written an equation here. This is what this number line represents. We may also be asked to take that number line and go ahead and write the sentence, which this is something you guys are pros at. It says complete the sentence. Blank units to the left or right of blank is blank. So how many units to the left or right? Jasmine. Careful. What do we want to do to make sure that this is incredibly clear since we're about to tell you which direction to? One thing I want to add here though. We talked about this yesterday. Because right now we're thinking about this 4 is telling me a direction to move forward, but you're also telling me to move left. So to kind of get rid of that confusion, I want to take the direction off of that first piece. That goes back to that other point. To take direction off of something, we add absolute value sign. So I want this first one not to be a direction, just a heads up. Hey, you're going to move 4 steps. Wait a second, I'll tell you, you're going to move left. All right? So we moved 4 units to the left of what number did we start with? 5. And we can see that that ended up to be 1. That's it. And so this is really no different than what we've done before. It's just kind of asking you to go with the process backwards. Given the following description, draw the number line that it represents. So this says the absolute value of 3 units to the right of 5 is blank. Well, we'll use the number line to figure out what the blank is. Where do we start our drawing on this number line? Where do I start on this number line? Show me with fingers. Fingers in the air. Where am I starting? Alright, I'm seeing some people show me 5 and some people showing me 3. Somebody who's got a 5 in the air. Explain to me why you have a 5 in the air. Jaquan.
Because the problem above 5 started it off, and then the first number of the equation or the expression is the first one.
Yeah, so this first one tells us how we're going to move. 3 units to the right. So that's telling us how we're going to move, not telling us where we're starting. So this is going to tell us where we start. We start at 5. Now I just gave away. The other piece that we need to do to represent this is it tells us how many units in which direction. So it says 3 units to the right. So I'm going to draw that. 1, 2, 3 to the right. Now we see that the answer here is 8. We also want to be able to write an expression for this. So again, when we think about the expression, we want to think about, well, what did I start with? Sammy? Yeah, 5. And looking at our number line, or also knowing that we moved to the right, that means we added a positive or a negative? Positive. And we added a positive what? 3. Simple. We'll do one last one. This is one where we start with the verbal description and then we move straight to the expression. So looking at the verbal description, it says 7 units to the left of 5. So again, looking at the description, where are we starting? Leah B, where are we starting? At 5. And it says we're moving units to the left. Everybody, does that mean we're adding a positive or a negative? Negative. So we're going to add a negative. And since we're moving 7 units, it's a negative 7. Now represent that on the number line. You guys are awesome at this point. We started at 5. A negative 7, we're going back 1, 2, 3, 4, 5, 6, 7. And that shows us that our answer is negative 2. Questions about that?